over the differential equations question that was part of the 1998 AP Calculus exam. This is number 4, which means there was no calculator allowed. Maybe I should specify that. No calculator. There we go. So let's look at the problem here. Alright, f is a function. F of 1 is 4, so they're giving you the ordered pair 1, 4. And the slope is given by this. Now, what they've done is they've given you a differential equation here. When they say the slope is given by that, they're simply saying dy dx, whoops, don't need to write in dots, do I? They're simply saying that dy dx is 3x squared plus 1 over 2y. So there's your information, and let's look at part A, which is going to be the easiest part. It says find the slope of the graph of f at the point where x equals 1. Normally that would just be f prime of 1, the slope at 1, but the problem is our derivative is in terms of x's and y's, so we have to find the y that goes with 1. Well, they gave us that. They told us that f of 1 is 4. So what we'll do is we'll find the derivative such that we have the ordered pair 1, 4. Not sure if that's a correct notation. I think it is. And we'll simply plug in 4 and 1, or 1 for x and 4 for y, into our slope here. So 3 times 1 squared plus 1 over 2 times y, which is 4. And that ends up being 4 over 8, which reduces to 1/2. So there's your answer to part A, which was probably only worth 1 point. I can't imagine them giving you a lot of points for that. Okay, part B, write an equation for the line tangent to the graph of f at x equals 1. Well, that's something we've been doing since August. Anytime you want the equation of a tangent, you always need a point and a slope, and this is pretty easy because the point was given to us, it's 1, 4, and the slope we just got from part A. So we're going to import our answer from part A, and that was 1/2. So we'll simply take our point y minus 4 and our slope and throw it into point slope form, equals 1/2 x minus 1. So there is the equation of the tangent. Then it says, and use it to approximate f of 1.2. That's linear approximation. That's where you take your point, your x coordinate, and instead of plugging it into the actual function, which we don't have yet, we're going to plug it into the tangent. So let's do that linear approximation. So we're going to say, we're going to plug 1.2 in for x in the tangent line. So I'm going to take my tangent and solve for y. So I'll do that just by moving that 4 over. So 1/2 x minus 1 plus 4. And then f of 1.2 is going to be 1/2 of 1.2 minus 1 plus 4. And you could stop right there, but I'm going to go ahead and clean this up. That's 1/2 of 0.2 plus 4. Half of 0.2 is 0.1 plus 4 is 4.1. So we get an approximate function value. Yeah, this is approximate, not exact. So let me change this to approximately. We get an approximate function value of 4.1. They gave you a huge hint here. They said find the tangent and use it to approximate. So they tell you to use it, the tangent line. Anyway, so there is part B. Okay, that was old stuff. That was stuff we did last semester that doesn't involve differential equations a whole lot. You could say that we use the differential equation to get the slope. Part C is where we get into the what you traditionally think of as differential equations. It says solve for f of x. So find f of x by solving the differential equation with this initial condition. So here we're going to actually separate and integrate. Remember, you must show the step where you separate your variables. So first thing we'll do is do that. Let's separate the variables. And this one we could do by cross multiplying. So when you cross multiply these two, you get 2y times dy is equal to 3x squared plus 1 dx plus, oh, that was right, dx. And once you separate the variables, and again, you must show that step. If you do not show the separation step, then you don't get any points for part C. So now that I've separated, we now will integrate. Left side is just going to be 2y. I'm sorry, y squared. Right side would be x cubed plus x, and don't forget the plus c. And that was 3 more points right there. You get 1 point for separating, 1 point for solving the y side, 1 point for integrating the x side, and another point for the plus c. Now we have 2 options. We could go ahead and solve for c, or we could solve for y. I think I'm going to go ahead and solve for c. So if we know that f of 1 is equal to 4, then let's see, that means 4 squared is equal to 1 cubed plus 1 plus c, and we know that c is going to equal 14. So once I solve for c, I'll go back and plug it back in to the c in my solution to the differential equation. Y squared equals x cubed plus x plus 14. Then we need to actually solve for y. So that we would take the square root. Y is going to be the plus or minus x cubed plus x plus 14. Now remember, it says find f of x. That means a single function. We technically have 2 functions right here. We have the positive square root and the negative square root. And to determine which one we need to keep, you have to look at your initial condition, and we are supposed to satisfy the initial condition f of 1 equals 4. That is a positive number, so we will keep the positive square root because we must satisfy f of 1 equals 4. So my answer that we'll use is the square root of x cubed, the positive square root, plus x plus 14. And there's our answer to part C. Alright, and part D, I was peeking ahead just a minute ago, and I don't know if you heard me hesitate somewhere in working part C. I was wrong at the very beginning about this being a non-calculator question. I was thinking about recent years. Now, problem number 4 is non-calculator, but I forgot in 1998 they actually allowed a calculator on all 6 free response questions, so just a little cranial flatulence there. So we are allowed to use a calculator, and we will use the calculator in part D. It says use your solution from part C to find f of 1.2. So f of 1.2 is going to be the square root of 1.2 cubed plus 1.2 plus 14, and we'll simply throw that in the calculator. And there's your answer when you plug this in the calculator. Remember, you must be accurate to the 3rd decimal. If you choose to write more than 3, that's fine, but they're going to look at the first 3. In this case, our answer would be 4.114. And before I end this video, we want to know if that's reasonable, if that's what you were expecting. And I was expecting somewhere around that because in part B, we used linear approximation to get the same value. They wanted us to estimate f of 1.2, and we got 4.1 through the linear approximation. So in part B, our f of 1.2 approximation is very, very close to the actual function's value, and so I'm satisfied with parts B and D. And that also, since the answers are close to the same, lets you know that you probably solved the differential equation correctly in part C. If I got a vastly different answer in part D than I got in part B, then either C and D are wrong or part B is wrong. So that's something about this problem that kind of helps you know whether or not you have worked it correctly.